Inverse trig functions. They can feel a little bit tricky, right? Like the rules are always changing on you. But what if I told you there's really just one core idea, one main rule of the game that makes everything else just click into place? Well, we're going to break down that rule and make these functions make sense for good.
Okay, so let's just jump right in with the question. It seems super simple, but it actually uncovers the entire problem we need to solve. So, what angle has a sine of 1/2? I bet you already have an answer popping into your head, don't you? But is it the only one? Well, if you thought of pi over 6, hey, you're right, but get this, so is 5 pi over 6. And because that sine wave just keeps on going forever, 13 pi over 6 is also a correct answer. And 17 pi over 6? We could literally stand here all day and list correct answers. So what's the big deal? The big deal is that for one single question, we have an infinite number of correct answers. And in the world of functions, that's a huge problem. I mean, a function is supposed to be predictable, right? One input gives you one and only one output. This means the sine function, as it is, doesn't really have a true inverse.
Okay, so that brings us to what we call the infinite answer problem. Let's dig into why these repeating functions, sine, cosine, and tangent, need a whole new set of rules to tame them.
In math, there's actually a formal test for this. It's called the horizontal line test. The rule is simple. If you can draw a flat, horizontal line anywhere on a graph and it hits the function more than once, boom, it doesn't have a proper inverse. And as you can see, trig functions fail this test spectacularly. I mean, everywhere you look.
So, what do? How do we get just one answer? Well, mathematicians came up with a really clever, really elegant solution. They said, if the whole function is the problem, let's just not use the whole function. We create a restriction.
Think about it. Instead of trying to deal with that whole endless repeating wave, we just don't. We basically make a pact, a universal agreement, to only look at one little piece of it. And we choose that piece very carefully, making sure it hits every possible output value exactly one time. No repeats allowed.
And that one simple move, just restricting the function, creates what I like to call the new rules. These are the official rules of the game for inverse trig functions, and you absolutely have to know them to get the right answer every single time.
And here they are. This table basically lays out our new playing field. For inverse sine, or arc sine, your answer has to be somewhere between negative pi over 2 and pi over 2. That's quadrant I or IV. For inverse cosine, your answer must be between 0 and pi, quadrants I and I2. And for inverse tangent, it's pretty similar to sine, just not including the endpoints. These are the only answers your calculator will ever give you, and they're the only ones that are officially correct.
Okay, listen up, because if you take away only one thing from all of this, let it be this right here. That new restricted playing field we created becomes the official set of answers, the range for the inverse function. Your answer absolutely has to fall in that specific range, no exceptions. That's the deal.
All right, theory's great, but let's see how this actually works in practice. We're going to put the theory into action and see how these rules make solving problems, even the tricky ones, pretty straightforward.
Okay, let's circle back to that very first question we started with. What's the inverse sine of 1/2? See, now we ask a different question. We ask, what angle that's inside our new restricted range has a sine of 1/2? Well, that answer is pi over 6. Is it inside the required range? Yes, it is. So that is our one and only correct answer.
Cool, let's try another one. This time with cosine. What's the inverse cosine of negative root 3 over 2? Remember, cosine plays by different rules. We need an angle in its range, between 0 and pi. The angle that works there is 5 pi over 6. It's in the correct range, so we're good to go.
Okay, get ready, because this next one is a classic trap. You see this on exams all the time. You see inverse sine of 5 pi over 6, and your brain just screams, they cancel out, the answer is 5 pi over 6, right?
Whoa, not so fast. If you just canceled them out, you're totally ignoring the biggest rule of the game we just learned. You're forgetting about the range. Let's walk through this the right way.
Here's the secret. You have to work from the inside out, always. First, what's the sine of 5 pi over 6? Well, that's just 1/2. Easy enough. So now the problem just becomes, what's the inverse sine of 1/2? And we already know the answer to that has to be in the arc sine range. So the final correct answer is pi over 6, not 5 pi over 6.
See? Once you know the inside-out trick, that trap isn't so scary. So now let's talk about avoiding the common traps to make sure you get the right answer every single time. This right here just lays it all out, plain and simple. Look at the wrong answer. Yeah, the sine of 5 pi over 6 is 1/2. That part's true. But who cares? It's outside the required range. So for an inverse function, it is the wrong answer. The only correct answer is the one that follows the rules and falls within that official range.
And the other big mistake is just getting the ranges mixed up. You can't just memorize one and hope for the best. You got to know which function lives in which quadrants. Arcsin and arctan are in I and IV, and arccos is over in I and II. Mixing those up is probably the fastest way to get a problem wrong. And look, I know this can feel like just abstract math stuff for a test, but it's not. Think about your phone's GPS. It's using trigonometry and signals from satellites to figure out exactly where you are. It needs one answer. It can't tell you that you might be in Ohio or you might be in Argentina. It uses these exact rules, these restrictions, to pinpoint your one single, unambiguous location on Earth.
So really, the big idea here is that sometimes, to get a clear, useful answer from a messy, infinite problem, you have to create rules. You have to narrow the playing field to find clarity in the chaos. So it gets you thinking, right? Where else, in technology, in science, maybe even in our own lives, do we need to choose just one right answer from a whole world of possibilities?